guys, this is Hannah, and for today's video we are going to have a video tutorial on how to solve a problem that deals with related rates, which involves derivatives. But first, we need to define what is a derivative.
A derivative is a function which gives the slope of a curve, that is, the slope of the line tangent to a function. The ordinary objects we see, airplanes, traffic lights, jeepneys, all have the application of derivatives. What we'll do now is to apply derivatives in a real-life problem. So in here we have our sample problem that deals with related rates. Jeremy lives in a house with a water tank in the shape of an inverted cone with a radius of 3 meters and a height of 6 meters. If the water is pumped in at a rate of 3 meters cubed per minute, find the rate at which the water level is rising when the water is 4 meters deep. So in here I have a diagram or an illustration of what our water tank looks like. So it is an inverted cone wherein this is our radius, which is 3 meters, and our height, which is 6 meters. Now we're going to find our problem, where our problem says find the rate at which the water level is rising when the water is 4 meters deep. So that is what we need to find in this kind of problem. We want to find how the height of the water is changing with respect to time. So in terms of derivatives, we're going to write that as dH over dt. So this is how the height of water level is rising with respect to time. So now that we have identified what we're looking for, let's see our given. So our given, we have our radius, which is 3 meters, our height, which is 6 meters, and the rate, which is 3 meters cubed per minute. So we are going to represent that with dV over dt, which is 3 meters cubed per minute. So that is given to us. This is the volume of water which is changing with respect to our time. So next, what we are going to find is our volume. Or what is the formula for a volume of an inverted cone? So we need to know that in order to solve this kind of problems. So our formula for our inverted cone goes like this: 1/3 pi r squared times h. So this is the formula for the volume of a cone. Now, the next part is a little bit tricky and you wouldn't usually think to do this, but we can just familiarize it, or like you can memorize it in this way. You see we have two, back in the illustration, we have two similar triangles here. This is going to help us solve our problem because we are going to eliminate a variable, which is the r. So we need to find the relationship between these two triangles. So we're gonna like draw another triangle here. Going to draw that. This is the r, 3 or h. Of course, this is 6 meters. Now, we remember in the similar triangles that with this, we can create an expression of r over h. When r over h is equals to 3 over 6, when we simplify that, we find 1/2. Now we're going to find what is the r. R over h is equals to 1/2, so we need to find what is the r. R is equals to h over 2. Okay, so that is the value for our rate. Now we're going to substitute this to our formula, wherein this volume formula, we're going to substitute that. So we are just gonna put V is equals to 1/3 pi r squared h. 1/3 pi, we're going to substitute the r, h over 2 squared times h. So we're gonna solve for that. H squared over 4 times h. Now we have the volume, which is pi over 12 h cubed. Okay, now we will start on actually solving for the rate of our solution. So when we solve for that, we have dv over dt. So this is the derivative of the volume with respect to time. So by this, we need to derive this one. We're going to derive it. So the derivation for that is pi over 4h squared. So in order to get this one, you're just going to take the first derivative. So you're going to subtract this with 1 and then multiply this one with 3. So we're going to get pi over 4h squared. So remember that we are implicitly differentiating here because we're taking v with respect to t. So we need to add dh over dt. Okay, this is exactly what we want to find. So now we're gonna isolate the dh over dt from this equation that we have made. So we're just gonna flip this one over here. So we're gonna get dv over dt times 4 over pi h squared is equals to dh over dt. Okay, so this is the expression on how you write dh with respect to time. Now we are going to substitute the value of the dv over dt and the h. So remember that the value of our dv over dt is 3 meter cubed per minute, and our h is equals to 6 meters. So we're gonna just substitute that. 3 meter cubed per minute times 4 over pi 6 meters squared is equals to dh over dt. So we're gonna solve that. We're gonna get 12 meter cubed per minute over pi 36 meter squared is equals to dh over dt. Okay, so we are just gonna simplify this one, so we can get 12 over 36 is 1/3 pi. This is the equation, meter over minute. So we're just gonna write that out. dh over dt is equals to 1/3 meter per minute. 1/3 pi meter per minute. So we want to write now our conclusion, wherein water is rising at a rate of 1/3 pi meter per minute. So now we have reached our answer. This is our final answer for our given problem that we have here. I hope you guys learned something from this video. Thank you.